Hello, my dear students. How are you all doing? I'm doing well too. Welcome back to my channel after a very long time. Since I know that your half yearly exams are approaching, you all must be stressed about some chapters. I know the calorimetry is one, and especially calorimetry numericals, isn't it? Don't worry, I'm there to help you out to solve the questions rather than numericals from the chapter. We'll try to understand the questions and then I'll teach you how to solve them step by step. So let us move ahead. Before going to the numericals, I want to give you a sheet of formula which will be used in the whole chapter, right? So एक formula sheet से start करते हैं, right? Okay. Now the very first formula or the relation that we are aware of, but we need to always remember. What you can do is you can take a screenshot of this sheet, formula sheet, and remember that in this whole chapter you are going to get numericals based on only these few formulae, right? सो कोई टेंशन की बात नहीं है अगर ये फॉर्मूले आपने याद कर लिए तो कोई भी स्ट्रेस की बात नहीं है आप कोई भी न्यूमेरिकल सॉल्व कर पाओगे कैसे अब हम देखेंगे ठीक है सो वेरी फर्स्ट रिलेशन इज बिटवीन कैलोरी एंड जूल नाउ बोथ ऑफ देम आर द यूनिट्स ऑफ heat energy, right? Joule is the SI unit and the calorie is another unit that is used to measure the heat energy. So 1 calorie is equal to 4.2 joules. It's precisely 4.18, but for all the calculation purpose, we'll use it 4.2 joules, right? Now next is heat energy. Now this formula we are going to use everywhere. मतलब अगर हम प्रिंसिपल ऑफ कैलोरीमेट्री भी देखें तो भी उसमें ये एक ही फॉर्मूला यूज हो रहा है दिस इज द मोस्ट कॉमन फॉर्मूला यूज्ड इन द chapter calorimetry. What is the formula? Q, that is heat energy, is equal to mc delta T. Now what does M stand for? M is the mass of the body, right? C is the specific heat capacity of the body, right? Specific heat capacity of the body. And delta T is the change in temperature. Small change, bigger change, whatever. Change in temperature, right? तो ये तीन फैक्टर्स है जो हीट एनर्जी भी डिसाइड करते हैं सो हीट एनर्जी इन अ बॉडी विल बी डिसाइडेड ऑन दीज थ्री फैक्टर्स फर्स्ट इज द मास specific heat capacity and change in temperature. Very important formula. We'll be using this throughout. Clear? Okay. Now heat capacity, which is denoted as capital C and dash. So heat capacity is C dash is equal to Q by delta T or Q divided by delta T. And it is measured in joule per Kelvin. This is the SI unit for heat capacity. There are other units also which you can use, but SI unit is joule per Kelvin. क्यों joule per Kelvin आया? Because Q, which is your heat energy, is measured in joule and delta T, change in temperature, is measured in Kelvin. So joule per Kelvin. Now next is your specific heat capacity, जिसे हम denote करते हैं small c से, right? Heat capacity is capital C with a dash and specific heat capacity is a small c, right? Which is equal to heat capacity divided by mass of the body. Because it is specific. It is specific means क्या है? Specific to a particular mass. How much is the mass? Unit mass. So अगर unit mass के लिए हम measure करेंगे तो उसे हम बोलते हैं specific heat capacity, right? So it is heat capacity divided by mass, which is C dash, heat capacity C dash divided by M, mass, right? Now it is also dependent on, like when we are saying heat capacity per Kelvin, मतलब temperature rise के लिए measure कर रहे हैं, so your unit for that is going to be joule per kilogram per Kelvin, right? Okay, so C is also equal to C dash by M, heat capacity by mass. So you can even have this formula, right? C dash by M, same formula has been given here, right? Now next is principle of calorimetry. What is the principle of calorimetry? So basically when a hot body and cold body are kept in contact, the hot body will lose heat energy and the cold body will gain energy, heat energy. Now assuming there is no loss of energy, we assume that in conservation of energy, right? So assuming there is no loss in the heat energy, heat whatever is being lost by the hot body is always equal to heat energy gained by the cold body. This is the principle of calorimetry. When two bodies at different temperatures are kept in contact. तो उसके लिए एक formula derivation है, which is M1C1. If you see M1C1, M1C1 stands for what? M1 one nomenclature use करते हैं जब भी hot body को refer करना है, right? So M1 is mass of the hot object. Then C1 is the specific heat capacity of the hot object. Then जो temperature difference होता है, तो higher temperature is always termed as T1, and the body at a higher temperature, whatever is the temperature, is noted as T1, and the body at lower temperature, its temperature is taken as T2, right? So cold object or cold body's mass is taken as M2, its specific heat capacity as C2, and temperature will be T2, right? अब जब ये दोनों भी मिक्स होते हैं, we know that the body, the combination or the mixture will attain a different temperature, which will be termed as T, right? So वो हो जाएगा T. T1 है आपका hot body temperature, T2 है cold body's temperature, and T is when you mix them up, the resultant temperature of the mixture. That will be termed as T. So combining that, if I have to write an equation, it becomes M1C1 T1 minus T, which is drop in temperature of the hot body, right? So hot body is going to lose heat energy. So uska calculation hai M1C1 T1 minus T, and the cold body is going to gain energy. So it is equal to M2C2 T minus T2, which is going to be always, what do we say, more than the cold body, है ना? तो temperature T क्या होने वाला है? T is going to be between T1 and T2. T is going to be less than, usually you always need to see that T is always less than T1 and T is always greater than T2, right? So heat gain में आपका क्या होने वाला है? T से Tt minus T2. So this becomes your equation for principle of calorimetry. We'll be using this equation when we solve numericals or questions based on method of mixture, right? Okay, now these two will be coming in the later part of, or rather B unit of the chapter. Specific latent heat, L is equal to Q by M. Q is again your heat capacity and mass is M, measured in joule per kilogram. Then एक और formula है जो इसमें frequently use होता है, which is heat energy is equal to power into time. How it is used, I'll show you with the examples, or rather the numerical, where is it used, right? So Q is equal to P into T. Q is your heat energy, P is your power, and T is the time interval. It is not temperature here. Remember, this is the time interval, right? So using all these formulae, we are going to solve some numericals. So let us go ahead and solve few of them. I have taken one of each type so that you understand how to go about solving the numericals. Okay, now the very first question. Calculate the heat energy required to raise the temperature of 2 kilogram of water from 10 degrees Celsius to 50 degrees Celsius, wherein they've given specific heat capacity of water is 4200 joule per kilogram per Kelvin. Now, when you solve any numerical, the first thing you're supposed to do is write down the given quantities. So I'm going to first write down whatever are the given quantities in the question. So I start with the mass of the body, which is M. How much is it? 2 kilograms, right? Now, we need to calculate the heat energy. So Q is unknown to us. What else is known to us? When you supply some amount of heat, which we need to calculate, the temperature of water will rise from 10 to 50 degrees. So there's going to be rise in temperature. So we will always note the change in temperature as delta T. In this case, this is going to be rise in temperature. Yes. And how much is that? That is equal to 50 minus 10 equals to 40 degrees Celsius. Or I can even write it as 40 Kelvin. You know the relation, right? Change, whatever change in degrees Celsius is the same is the change in Kelvin, because they have the similar scales, right? So only it is applied only to delta T, only to the change in temperature, not everywhere, right? Okay, so एक और चीज क्या दिया है? Specific heat capacity. So we denote specific heat capacity as small c, which is equal to 4200 joule per kilogram per Kelvin. This is how you're supposed to write the unit. Okay, now we go back to the formula sheet and we see which formula to be used. I need to find out what is heat energy supplied, right? So we'll go to the formula sheet, and as I said, most of the numericals will use this second formula rather, yes, which is Q is equal to mc delta T. So we use the same now. I write the equation here, I write the formula Q is equal to mc delta T. Now I substitute the values. I take m as 2 into c as, now you have to make sure that whatever is your mass unit, same has to be your specific heat capacity unit. अगर इसको ग्राम में दिया है, then you have to convert the mass also in grams, right? So both need to be in the same system of unit or SI unit. अगर इसमें SI है तो yes, both of them need to be in SI unit. So then I substitute the value of C 4200 into delta T is 40, right? So when you solve this, you get the answer as 3,36,000 joule. So this is my first answer. Isn't it easy? Only same, like single formula to be used everywhere. Okay? Right. Now the next question. A piece of iron of mass 2 kg has a heat capacity of 966 joule per Kelvin. Find the heat energy needed to warm it up by 15 degrees Celsius, and second, its specific heat capacity in SI unit. So in a question, we have two sub questions, right? Important part in these kind of numericals is to identify the quantities which are given to you, right? So we start with the very first step of writing the given quantities, correct? Okay, so what is the mass of the object given as? 2 kilograms. Okay, good. Then heat capacity. Now we are talking about heat capacity. It is denoted as capital C dash, which is 966 joule per Kelvin. And what is unknown? Okay, is there anything known to us more than that? Yes, it says heat energy we need to find to warm it up by 15 degrees Celsius. So they've given that the body's temperature will increase by 15 degrees Celsius. So they have also provided the delta T, which is 15 degrees Celsius, or I can even write it as 15 Kelvin, right? Now unknown things. First is your Q, heat energy, and the second unknown is your specific heat capacity, which is smaller c. Okay, so we'll solve the first part first. Can we solve this? Q? Yes? Okay. Q. Q is equal to, yes, which formula to be used now? Can we just go back to the formula sheet and check? Yes. Do I have a heat capacity given? Yes. Heat is not there. Delta T is there. So can I use this formula over here? C dash is equal to Q by delta T. Yes, I can use this, isn't it? Okay. So I use this. C dash is equal to Q divided by delta T. So I write C dash is equal to Q divided by delta T. So my Q becomes what? C dash into delta T. Yes, what is C dash here? 966 into my delta T is 15. So what is the answer I'm getting? Q. Q is equal to, I'll get it as 14490 joule. So 14,490 joule is the heat energy needed to warm it up by 15 degrees Celsius. Now the second part of it, what it says? The specific heat capacity in SI unit. Now I have the formula, I'll write it down here. Q is equal to mc delta T. I said one formula is applicable everywhere. So now I need to find out this. Okay, do I have Q? Yes. Do I have M and delta T? Yes. So I write C is equal to Q by divided by M into delta T. So I just substitute the values. 14490 divided by mass is how much? 2 into 15, right? So I get the value of C as 483. When you solve this, you will get the answer as 483, and let us see what should be the unit. This is in joule, this is in kg, and this is in Kelvin. So I write this as joule per kg per Kelvin, right? So this is my second answer. So first answers are heat capacity and the specific, the heat energy, and the second is the specific heat capacity. Is that clear? Okay, so can we move to the next question? Right. Now, the next question says an electric heater of power 600 watt raises the temperature of 4 kilogram of a liquid from 10 degrees Celsius to 15 degrees Celsius in 100 seconds. Calculate the heat capacity of 4 kilogram of liquid and the specific heat capacity of the liquid. तो जैसे हमारा procedure है, we always start with writing the given quantities, right? Okay, so I first write down the given. Now what it says, we have been given with a power. जो हीटर है उसका पावर दिया हुआ है 600 watt. So can I write down P as power is equal to 600 watt? Yes, I can write that. Then what is the mass of the liquid that is going to get heated? That gives me M is equal to 4.0 or 4 kilograms. Now change in temperature, ये क्या होने वाला? Increase in the temperature. How much is it? From 10 to 15. So what will be my delta T? I will get the delta T as 15 minus 10, which is equal to 5 degrees Celsius, or I write it as 5 Kelvin. Or, okay, this is or. I can write it anyways. Right. Now, what is unknown to us? Unknown क्या है? Heat capacity, which is denoted as C dash, isn't it? तो वो हमें पता नहीं है, and also smaller c, that is also not known to us. Right. अब क्या करते हैं, अभी हमारे पास ये एक है तो पावर दिया हुआ है, so we go back to the formula sheet and I told you something, we are going to use this power formula somewhere. So where is it being used? In this example now. So Q is equal to P into T. Heat energy is equal to power into time. So I will use that formula over here and I will calculate first heat energy. Q is equal to P into T. So what is the value of P? 600 watts hai, and time is 100 seconds. Okay, I forgot to write the time given here. T is equal to 100 seconds. Right? Okay. So how much am I getting the heat energy required? Is going to be 60,000 joule. Yes, okay, 60,000 joules is the heat energy required. Now for C dash, तो ये हमारा first answer है. What is the formula? C dash is equal to Q divided by delta T. Right? कहाँ था ये formula? देखना है? Okay, देखो. C dash is equal to Q by delta T. Right? Okay, so I use that formula. I come here, I write 60,000 divided by delta T, temperature change कितना है? 5. So I get C dash is equal to how much? 12,000, or, and what is going to be the unit? Joule per Kelvin. SI unit है ना? Or else I can write this as 1.2 into 10 to the power 4 joule per Kelvin. ऐसा भी लिख सकते हैं. ठीक है. अब C dash आ गया हमारे पास, M भी है तो हम C फाइंड आउट कर सकते हैं. Which formula? Yes. Okay. Second part of the question, specific heat capacity, smaller c is your heat capacity divided by mass. Can I use that also? Right. So ये क्या हुआ अपना? 12,000 divided by mass was 4 kilogram. So I get C is equal to, but this is specific heat, so it's always going to be, the temperature is also coming in your unit, right? So I write this as C equals to 3,000, which can also be written as 3 into 10 to the power 3 joule per kg per Kelvin, because it is per unit mass, so I need to write this also, and it is also the temperature that I need to mention. Correct? So we got both the answers here. We got C dash and we also got C here. Okay, let's move to the next question. Now, a mass of 50 gram of certain metal at 150 degrees Celsius is immersed in 100 gram of water at 11 degrees Celsius. The final temperature is 20 degrees. Calculate the specific heat capacity of the metal and assume the specific heat capacity of water as 4.2 joules per gram per Kelvin. Now, if you observe, this is a question of method of mixture and हम इसमें use करेंगे principle of calorimetry, right? And the way I told you, the hot bodies, the hotter substances will always have a nomenclature as 1, right? So in this only I'll write down, this is my M1, right? Temperature ये 150 हो गया T1. Then this is my second substance which is cold M2 with a temperature T2. And जब mixture हो जाता है तब क्या होने वाला है, उसका final temperature is going to be T, which is going to be smaller or rather lesser than T1 but greater than T2. So that is your T. तो इसमें ये हो गया T, right? अब ये क्या है, इसका ये है this is your C2, right? Now you have to calculate the specific heat capacity of the metal. तो C1 हमें find out करना है, C2 हमें दिया हुआ है, right? I will write down the quantities first. So I'll write M1 is equal to 50 grams and please observe the units used. Mass gram में है तो आपका जो specific heat capacity that is also in joule per gram per Kelvin, right? So we don't have to change anything. We use the values as it is. So M1 हो गया 50 gram, M2 is 100 grams. Then C1 is something which we need to find out. Then what is the value of C2? C2 is given as 4.2 joule per gram per Kelvin, right? Then what is the value of T1? T1 is 150 degrees Celsius and T2 is 11 degrees Celsius. And to that हमारा final temperature body का क्या है? 20 degrees Celsius. Always and always remember your T is going to be always, I would say, greater than T2 but lesser than T1. Okay? Correct है, ये check कर लो. T1 is 150, उससे कम है 20, उससे कम है 11. Okay, so you can do it in two ways. So you can first calculate the heat given by the hot body by using the formula M1C1 and delta T, or else you can use the combined formula, which is, I'll write the combined formula here. So now this is assuming. So what you're supposed to write here, assuming there is no loss of energy. We say a principle of calorimetry. Is M1C1, as I said, what is the formula? T1 minus T. तो इसका drop in temperature होने वाला है hot body का and cold body का gain in temperature. So I write this as M2C2 T minus T2. So we have to simply substitute. ये एक तरह से easy हो जाता है. अगर आपको अलग अलग calculate करना है तो the left side of it you can calculate separate, then right side and then equate them. Okay, so M1 is 50, C1 is unknown, T1 minus T. So this is 150 minus T is 20 is equal to M2, which is 100 gram, into C2 is 4.2 into bracket में आएगा T minus T2. T minus T2 is 20 minus 11, which is 9. So I write this 50 into, ये आएगा 130 into C1 is equal to 100 into 4.2 into 9. So when I solve all this, I get my value of C1 is equal to 0.582, which is going to be joule per, now this is in gram, right? Because हमने ये gram वाला लिया है per Kelvin. Okay, this is how we get the answer for this question. So take your time and solve it slowly. The next question, it's a small one. 1 kg of water is contained in 1.25 kilowatt kettle. तो ये क्या दिया है आपको? Again, power is given. Calculate the time taken for the temperature of water to rise from 25 degrees Celsius to its boiling point, which is 100 degrees Celsius, and specific heat capacity is given as 4.2 joules per gram per Kelvin. Now compare this. This is given in joule per gram per Kelvin, and water ka mass is given in kilograms. So better to convert that into grams. Okay, so I write again the given quantities. So I write mass is 1 kilogram is equal to 1000 gram, right? Now power is how much? 1.25 kilowatts, okay, which is 1250 watts. इसको multiply करेंगे 1000 से, then we'll get it in watts. Then C is 4.2 joule per gram per Kelvin. And what else? Temperature difference. Rise in temperature, delta T is 25 to 100. मतलब how do I calculate that? 100 minus 25. So rise in temperature is 75 degrees Celsius or 75 Kelvin. Okay. So from this, I need to find out the time. So first of all, I need to check the formula. ये वाले से check करते हैं. Q is equal to P into T. We have this formula. Power के साथ अगर energy calculation करना है तो we have this, right? So first of all, let us find out the Q. How much is that? Q is equal to MC delta T. Do we have all the figures here? Yes. So इसमें we have taken 1000 into C is 4.2 into 75. So we get the answer here as 315,000 joules. ठीक है, 3,15,000 joule ये Q आएगा. Now we use this formula to substitute. Q is equal to P into T. So how much is this? 315,000 equals to power is okay, 1250 into T. So your T calculation becomes 315,000 divided by 1250. So when you solve this, you will get the time in seconds as 252 seconds, right? अगर मुझे इसको split करना है, so that becomes 4 minutes and 12 seconds. Right? So how much time was required to heat that water from 25 to 100 degrees Celsius? It took around 4 minutes and 12 seconds. So if you try to split the question in different parts, first of all, इसमें important क्या है? Identifying the quantity. जो भी दिया है, क्या है, कैसे calculate करना है. And formally, I've shared the formula sheet with you. It is very easy. Nothing comes out of this formula sheet in this particular chapter. So follow that and you will be able to solve any numerical based on the calorimetry. I hope this video was helpful for you, and if you find it so helpful, please share it with your friends. Like, share, and please subscribe to my channel. Thank you so much.